water is H2O, right?
Yeah.
So water is 2 hydrogens, 1 oxygen. So the oxygen is also a lot bigger. So you look at the periodic table, oxygen is 16 on the atomic mass. Hydrogen is 1. So the oxygen is 16 times larger than hydrogen. So this isn't a very accurate picture of the two because hydrogen is much, much smaller. Now there is such a thing as when you have more than one water molecule as hydrogen bonding. Hydrogen bonding is a very, very weak bond between the water molecules. And that's where the dotted line is. See that dotted line? So now, when you deal with slime, you've always, as a kid, you guys have always played with slime. I mean, you haven't even as a kid?
Yeah. I
Okay,
played with it today.
But you know what it is. Okay, so if you stretch it slow, it stretches, right? If you pull it, huh? If, well, okay, but the point of that, I'm trying to say, if you pull it fast, then it breaks, right? And that's because it's a borax molecule. It's a borax molecule, and borax is a bigger molecule. It's a bigger molecule than water by a lot. Okay, so think about, think about my knuckles is quite a bit bigger than my pinkies and my thumb, okay? Right, so we got water molecules. But now think about borax, which is like my arms. So water is a liquid, and the reason it's a liquid is because of hydrogen bonding. Okay, every time every thousands of millions of times a second, those hydrogen bonds are breaking and forming, and that's what makes it a liquid. With slime, it's the same type of thing, but it's a bigger molecule, so it takes longer to find the next hydrogen bond. So if you pull it slow, it can find the next hydrogen bond, but if you pull it fast, it can't find the next hydrogen bond. And that's why it breaks versus stretches. Okay, so water uses hydrogen bonding. You guys want to? Okay, so hydrogen bonding, one of you, go over there. So hydrogen bonding breaks, forms, okay? And it creates that liquid format. Okay, now if as the water gets warmer and warmer, that hydrogen bond becomes weaker and weaker, where it no longer forms anymore. And what state is that?
Gas.
Gas. Okay? And as it gets colder, then that hydrogen bond forms again and keeps on, and that's condensation, right? So that's condensation. And as it gets colder and colder and colder, it gets really strong. So strong you can drive a truck on it, okay? Well, right? Ice road truckers, right? Same. So anyway, it becomes really strong, and it no longer breaks anymore. And it forms a crystal structure, and the crystal structure is like this. What does that start to look like?
Snowflake.
Snowflake. So on the side of our bowl, we start to see snowflakes form. Yeah, go ahead. So you see snowflakes form. And as time goes on, those snowflakes will get bigger and bigger. And they'll get up to before they start falling off, about a quarter of an inch. But crystals, anything that's a crystal, forms over time. It doesn't happen all at once. It forms over time. And what happens is that you have one crystal structure form, and then it adds on to it. And so each one of these chains start adding on, and that's why you get that snowflake pattern. You wouldn't be able to see it even under a microscope at this level. But as it starts to keep on growing on itself, then you can start to see that lattice structure. So now, if if you take, and water crystals also change depending on what's in it. So when you see snowflakes, the reason you see different unique shapes or crystal structures, they'll all have this hexagon shape. Every crystal will have that shape, okay? But they may be thicker or have different, designs coming off of it. And the reason for that is because it's what is the dirt or whatever's in the water. The minerals, the dirt, the cream. So ice cream. So if we take ice cream mix, okay, it's a liquid. So what do we know what makes it a liquid? Water. Okay? And it's hydrogen bonding that makes it a liquid. If I take milk, which is mostly water, and put it in an ice tray, and then go freeze it, and then as it starts to thaw, go take a fork and kind of lift the layers up. And look at the water crystal structures and how they get really elongated. They almost look like wood chips. And the reason that ice cream manufacturers put mix-ins in their ice cream is because they're trying to hide the crystal structure. So your tongue can detect all the way down to 8 microns, 1/8 of a meter. That's how sensitive your tongue is. So you don't want to feel those, so you put candies in it so you don't feel the crystals. You think it's the candy. So when I ever do a presentation even like this, when I make the ice cream, I never put a mix-in it because I want you to see the texture. I want you to see how those very, very, very small water crystals feel. And so anyway, so I'm going to make one batch of ice cream right now, and then we're going to do one last experiment. And so usually it takes about 20-30 minutes to make a batch of ice cream. We're going to make it in about 15 seconds.
Ooh, that is cool.
Ooh, it's cold.
Okay, that's
Wow, that was really fast.
all right.
That looks
Now stop it one more time and then